Can you see my screen? Yes, okay. So this handout should be uploaded. I think we'll uploaded it on Canvas. You
Yeah, it's on Canvas.
Yeah, you should have access to this PDF. So basically, this is just a recap of the project slides that we had, and then we basically have also the installation instruction, which is on the GitHub's repo that I shared with all of you, or added all of you to. So basically, the first week here, this is just a fast recap on the milestones, right? So first week, we're supposed to, hopefully by this point, you've tried out the environment and you try to install the environment. And then you should be seeing some cars running in RViz, and then you should have some questions on how things work. And then you're also supposed to submit this project proposal. I think it's due today. So pretty much everybody should be done with these two tasks. And then evaluation will give you a proposal feedback today. Maybe if it needs further improvement or clarification on your approach, we'll let you know today. Also completion, this is more for your own sake, because we can't really check that everybody has installed a simulator. But it's just easier if you get started earlier, because all your tests are going to be ran on this new environment. It should be pretty easy to install, and the interface should be pretty straightforward. And the guidelines here are the same as those in the slides on what your project proposal should include. And then next week, basically, we'll be evaluating your single car runs. So this you should already be able to do. This is basically the race that we cancel. So this is the peer pursuit race where you have to go around the track, but now you might have a different track. We still have to decide whether we want to use Skirkinich or we want to use Levine, but it's going to be a single car run with no obstacles. Your solution from peer pursuit should still work, and leaderboard will be maintained. So currently I'm working on how you can basically do this online submission type thing where I run a server on my site, and then you'll need to give me basically a link to a repo of your code and an entry point, basically a script on what to run in your code. And then we'll score all the teams in the same environment, and then we'll run a leaderboard. So I'll have more information on this later on this week. I think this is currently, the leaderboard is currently not up yet. And then week 3 and 4 is basically you need to demonstrate. So first of all, you need to demonstrate your single car run can avoid static obstacles in the map. And then we'll give you some starter agents that you can also run against. So that will be basically a dynamic obstacle. So the evaluation for week 3 is we want to check how frequently you collide with either the environment or the obstacles or the other agent, and then we'll give a score based on that. So you ideally will want to avoid all collisions. And then we also need to, you'll also need to present your project proposal that's modified based on our feedback to the instructors. And then lastly, the last week is that you will be running the final race and the 2-car racing benchmark with instructor provided agents for the first round. And then you'll be running a round robin tournament between each team after you're seeded by this benchmark. So basically what we check here is that we also check for collision frequency, which hopefully is 0%. And then we also need to see basically rank you with the win rate against the other agent and score you according to the ELO criteria. So our provided opponent agent would be will be of different, basically how good they are, right? If you race against a really good one, you'll get more points in your ranking. So yeah, that's basically the last weekend, the final race. And then next, I'll go over how to install this environment. This format is not as nice as the GitHub README, so I'll just come over here. It's exactly the same content. So hopefully, let me check. All of you have, whoops. All of you have, yeah, 13 of you. What's the difference between task 2 of week 3 and task of week 4? Right, so your evaluation criteria is different. Right, this is only looking at your collision frequency, but here we're evaluating not only on collision frequency. We only need to check how good you are by checking your win rate against other agents, and then give you basically an ELO score. So here, this is like a baseline thing. You can just finish without colliding, and we don't care about if you win or not yet. But here, you need to win, basically. Okay. So back to, yeah, so 13 of you have sent your GitHub username to me. I think I invited everybody. And then just a quick poll. How many of you have tried to install the environment? Just type in chat. Okay, that's 1, 2, 3, 4, 5. Okay, is it working as a documentation suggested at all? Are you having any trouble? No? Okay.
Sorry to interrupt. I just had one thing which I saw, which is that the opponent card starts automatically. Is that expected?
Oh, that's because if you look at the, all right, I'll go to that. So I provided basically a dummy agent here. So it's publishing a 0 speed Ackerman drive stamped. And the opponent agent is triggered by you publishing a drive message. So this is publishing as soon as this whole thing starts.
Okay.
So that's why the opponent agent is also triggered. Okay. Okay. Well, for the ones that, for all of you that didn't install the environment yet, I'll basically walk through what you'll need to do to get it running. So first of all, you need to install Docker on your system. Basically, this is only tested on Ubuntu. And you'll also need ROS on your host system, which I think kind of limit your selection of operating systems to just Ubuntu. I'm pretty sure it doesn't work on Windows. I haven't tested it on Mac OS, but I imagine that it wouldn't work because you'll need to get ROS working too. So I would just suggest stick with Ubuntu. If you are having trouble getting a Ubuntu installed, just talk to us and we'll try to figure out a solution for you. Basically, the first step that you need to do is to follow the instructions from Docker to basically install this on your system. It should be pretty simple. Just walk through all the steps and then test out. Basically, you need to test out if Docker is running. So just go through this link here. And if you want to know how Docker containers work, you shouldn't have to change anything on the Docker side, so you don't really need to know everything about it. But if you know what the concepts of Docker and what it actually is, you can check out the second link here. It's pretty straightforward. They explain it pretty well on what Docker actually does. Okay, maybe I'll show a terminal window. How do I share both? I would suggest everybody just go to this link and then open up the README and follow along if you want to. All right, so the first step is you want to clone that repo we have into so I'm on the left terminal here. If you see in my source directory in the Kekin workspace, I have a F110 gem ROS repo here. This is the repo that has everything, the repo that I just linked. Basically, what you want to do is once you clone this, you can go into this repo here. I'm on the right terminal now. Once you have Docker installed, you should be able to just build the Docker container. I've written a bash script, so it should handle everything automatically. So you see that it's going really fast here because I've built it before and everything is cached. So usually this whole process of building the environment takes around 5 minutes, depending on the system that you're on. And then you should see like successfully built, successfully tagged, everything like that means that you built it successfully. And the next step is to actually run the Docker container. So this is the second script I provided. It's just docker.sh. So this should start a Docker container, and then it should start an entry point launch file, which will launch a bridge node from the Docker to ROS, and also start the underlying gem environment. So you don't have to worry about that yet. So as you can see, this is basically running a launch file. And then once this step is done, you want to go back to your host system. First of all, just Kekin make, and then source the setup.bash because we have a new package. And then what you want to do is, if you want to check out like an example launch file, you can just launch the template that I provided. So this will bring up a bridge on the host side. It will also bring up RViz. It also brought up the dummy node that I showed before. I'll change that to the RViz window. All right, so you should see something like this. So the orange car is the opponent. So now it's just doing a very simple waypoint following. And then the blue car is your ego car. Right now it's just doing, not doing anything. It's just publishing a drive message with 0 speed. You should also see like the laser scan. It's raycasted onto the other agent. So if you want to use that, it's also there. Yeah, so this is what the environment should look like when you test out stuff. And then also once the environment is running, you should be able to see I'm on the left terminal here. If you do ROS topic list, you should see the list of topics that's being published or being subscribed to. So for example, I can echo scan. So this is since the bridge on the host is not running, it's going to be the same scan over and over again, but it's the same format that you've seen before. What else is available? We also have the ODOM. This is the Ego Cars ODOM. Right, as you can see, it's just sitting there, not moving. Then you also have opponent ODOM available. So this is the host of the other car. Since we killed the bridge node on the host, it's not running anything, so it just stopped at whatever the last place it was at. What else is available to you? Right, so those are I think scan, the ODOM of yourself, the ODOM of the other car. Those are probably the most important topics. Oh, you also have this race info topic that I made. So it will show you the lap count of both the ego agent and the opponent agent, right? So this might be useful. And you also have the elapsed time. So this is the time from the first drive message that you published till now. So note that this might not be exactly the same as the time that you might see in Arvis, because the gym environment has its own. It keeps track of its own timing, right? It's basically stepped by your input. So the time increased by a certain amount once you get given a new input. So if this doesn't match up with the Ross time that you see in Arvis, don't worry about it. So you should use this time um, as like the time the lap time that you should be looking at. Then you also have two booleans, basically ego and opponent. Um, this is for colliding with either the other agent or the environment. Um, we will update the simulator later on to handle like what happens during a collision. Right now, it just keeps going as it wants, but you should be able to see if it's collided or not. But we'll push a new update very soon on that. Um, any questions so far?
I don't know if we should. I want to ask, like, where's the best way to build like our own gym environment for because we're going to use RL and yeah.
Oh, so you don't want to use the ROS at all, environment at all? Is that what you're
No,
saying?
we do, but I was just wondering, like, what's the logistics of how to do that?
Just interact with it in the container.
Okay.
I mean, there is another repo that's underlying that handles all the underlying physics. That's in the repo, right? So
Hey Billy, don't we have a F110 gym
yes, we do.
repo as well?
That's what this clones into. So it's not going to have a like a the documentation might not be as straightforward as this one, but this one basically this is just a bridge. And inside the Docker container, the physics is all handled by this repo, F110 gym. If you really just want to use a gym environment, you can check this one out. But
No, I'm fine with using what you guys have. I just want to like where do we define like the reward function and all that kind of stuff.
oh, so
Like
right now the only one that's available to you is the lap time.
okay.
But they could make another one, right? You want to show them where that's set up in the gym?
That's just you just every time you step it. Right now it doesn't have anything in it. It just returns you the difference, or maybe basically how long that step took. Right, it's a fixed time step. Right, so the reward here is just the the time step that's between each step. Right, so you would basically accumulate this step reward, and then you'll get a lap time. You need to change.
So I was wondering, like, do we should we build like something that like overtakes this these functions like these, or I guess I'm a little confused.
I mean, so when you do
discuss
the race, you're not getting the reward, right?
Yeah.
So
This is just during training.
You can do whatever you want in training. That's part of your projects, right? And so if you need a gym environment, you just saw where the reward is defined. you can clone this and fork it or whatever and make your own reward.
Okay. Yeah.
I have a question on the two-way race, like when you have two cars. Are we communicating? So I would assume that we are sending our drive message into a topic, and you guys are probably reading that drive message from the topic and applying it. How does the time work? I know, like in gym, you have like steps. So I would assume in our end, we will be publishing drive messages like frequently. How do you guys decide, like at each time step, which one of us is sending what drive message? Because it's going to be continuous, right? Like I don't think the drive message is going to be like based on time frame of OpenAI. Gem.
So currently, right, the only way that you can publish a new drive message, or at least most people's agents, would be I get a new scan and the particle filter updates my pose. And so this is a strictly easier situation, right? When you run particle filter, you'd like it to come in at 30 hertz exactly, but you don't know for sure. There's some jitter in the arrival of those messages. In this case, you're going to know exactly the delta t, and you will be able to know exactly that, you know, in the next delta t, I'm going to get this this opportunity to step again.
I mean, they don't get to control the stepping explicitly in the ROS bridge.
I understand that, but you can think of it like a sensor that has very consistent delta t's, right? Your observation is like taking care of the sensor fusion part for you. I don't know. Do you agree, Billy?
I mean, you.
My question is, if I send my drive message, how do you guys decide? Like, let's say I'm continuously sending drive messages, and my opponent is also continuously sending drive messages, and let's say our code or their code is faster. Like one of us is, I guess I'm having difficulty how the ROS drive topics combine with the OpenAI gem, like the timeline. I guess that's the part I'm confused about.
The other drive, the opponent agent that you'll be facing, it's only going to trigger a new plan step to create a new action when it gets a drive message from your agent. So it's just going to grab one from your drive topic, and then it's going to plan for both agents and step the sim. Once that's done, it goes back to look for another drive message from you. So it's triggered by all you publishing a drive message. It doesn't do anything if you don't publish a drive message.
Yeah, so that's my question. Do we have to send a drive message in a specific way?
No.
Because like in our code, do we have to like hear something from the opponent and then do the drive, like do the calculation, or do we just like do it regardless of what it?
That's up to you. You have the full observation at that time that you're planning, right? You have the scan of yourself, you have the odometry of yourself, and you also have the opponent's odometry.
I mean, let's be a little more specific, Billy. I think that shouldn't they? What's the point in sending another drive message if nothing has changed in the world, according to your observation?
I guess what I'm asking is that is there a topic that you guys sent us that asks us now you make a new plan? Like, is there something that would tell us, okay, now it's time to make a new plan or like do something?
No.
Okay.
There is no such topic.
Okay. So, okay. I guess we can talk later, but I'm so confused on how we're like us and the opponent are going to be in the same timeline.
Every time you do something, the opponent does something. So there's what you're able to see, and then there's what we're able to see inside Jim. Does that make sense?
We can talk later. No. I don't want to like take a lot of time.
I mean, nothing has changed for you guys. You're still getting ROS messages, right?
Yeah, no, I agree with that.
So whatever you were doing before, keep doing it. And I would say that you can trust that on the other side, you know, we will handle the synchronization part.
Okay. Yeah. So do we have to like, I guess what I'm asking is, do we have to publish, because I know that you guys are sending us time from the OpenAI gem, like the time step from the OpenAI gem. do we use that time when we are publishing our drive message? Like, do we use a different signature for our drive messages, or do we not change anything and just publish it?
Just
you
publish.
You should just think that time is a score, not in terms of time, because it's not really real time in terms of what you're seeing in ROS.
Okay.
Is that it's more like a reward than a time.
I see the confusion.
Yeah, I'm really confused.
Okay, so the time that you're getting out of gym, that's like your reward function. So the sooner you finish the race, right, I guess it's more like a loss function. The sooner you finish the race, the less time it took, the better you did. You're not to use it as anything else, right?
Okay.
You're supposed to just publish your drive messages like you were talking to the simulator before. Nothing's changed.
Okay, so our goal, winning the race, means not colliding with anyone else and finishing the race before, like, in a shorter time than our opponent.
Yeah.
The time that is being published or being sent to us.
Yeah.
Okay.
The reward time.
Yeah.
We can adjust this stuff if there's problems with synchronization, but our initial experience is that this will just work.
Just one small question. The time that you guys are defining is the step time, right? Like when you make a step, like the time it takes to do the step.
Yep.
So the processing time, so like the time that we take for each opponent takes for processing information wouldn't be included in that time period. It would just be the step time.
Yeah, that's just the physics time step. Yeah.
Okay.
Not
all right, thanks.
Yeah.
Not like the general coding run.
The opponent agent runs very fast.
Okay.
Relative to the step time.
Mm-hmm. No, I'm talking about our code, not the opponent. I'm just like making sure like it is not how fast the code runs, but how fast is the car in physics run.
Yeah, you should think about this as running on the real car, right? You don't want your planning code to run anything less than 10 hertz, probably.
Okay.
So I think that also answers Samir's question. How low can the frequency of drive message publishing be? It needs to be reasonable. Like right here, we don't have any mechanism to publish to punish like the slow publishing of your drive message, but just think of it as fast. Running on the real car. How fast do you want it to run on the real car?
If it becomes a big problem, I think we do have a mechanism to punish it, but we'll hold off on that for now. Let's just
we'll try to be fast. Just making sure.
See what everybody does, and if it breaks our simulator, we'll fix it.
Sounds good.
But the best way to understand this would be to like hook up your Pure Pursuit agent now and just try it out. It's useful feedback for us.
Would it be possible, I'm not sure what other team wants, but would it be possible just for the first race to stick with the Levine map, because we have most of it done? And not that it makes a difference if you go to a different map, but would it be possible to just do the Levine map and see how everything works and then maybe change it to a different map? It's a suggestion. You guys don't have to do it.
Let us talk about it, but probably.
Yeah. Okay.
I don't want to give an answer without instructors discussing.
Okay, thanks.
I have one question about the environment. So I noticed this is an environment.step function. Does it have the dynamics of the car encoded in it?
You mean in the gym environment?
Yeah.
Yeah.
So it's using an underlying C++ code. It's not in Python.
Okay.
A little bit. It's basically sending a protobuf to the C++ code.
So if we need to get the dynamics, is this the way to do it? Like through this step function?
It's exactly the same as the raw simulator you've been using. I think I have a question on that.
I think Billy's reply was probably the best.
It's on Slack.
Yeah, so I have the paper here and also where you can find the dynamics.
Okay, but if we choose to implement in Python, could we just use that function?
You mean the step function?
Yeah.
This is not exactly just getting a physics update. It also handles a lot of different stuff, so I wouldn't do that.
Okay.
Also,
Thank
this means that you'll need to set up your set up the all the environment dependencies on your local, which I don't recommend.
Right.
Yeah.
In general, if your goal is to sort of exploit the synchronous nature of the simulator, please don't. So maybe you can message us privately, like more specifically what you want to use this for. And then we can sort of create a FAQ that says, yes, this is allowed, or no, it's not. In the case that it becomes problematic, we can add random noise to the observations and stuff. Great. So if the reason you want this is to get future sensor observations faster than the other, then you should be able to through ROS. That's kind of not good. That's not the point. But if you want a model for MPC or something, just have a look at the link that Billy sent you. It's got 5 or 6 different models of varying complexity, and it's probably useful. There's also a Python implementation that goes with that paper.
Okay, that sounds good.
So
yeah,
if
because you just need it for MPC.
If you just need a dynamics model for MPC or something, check out Billy's link to the paper. They have associated good Python implementations. They're probably not suitable for MPC though. You're going to want to linearize.
Sure.
All right. Any other questions?
Has anybody tried to install this and
Yeah.
failed?
So this is not good. Only 6 unique cloners. So everybody, try it out, please.
Yeah, I just ran it. It was fine. Like I was able to get the opponent card driving or whatever.
Do we have anybody with like OS issues, like not on Linux, that is stuck? Also, has anybody tried to do this in a virtual machine? Does it work? How slow is it?
Especially, can I ask a question specifically for that? Is there any like help in terms of like financially or something for like I don't know, Google Cloud or Amazon Web Services for like using GPUs and stuff? If you want to,
have you ever signed up for Google Cloud before?
Yeah, I think you
I've
get
used it for one of my classes. I already used that. I already used that $200 and I think something they gave us for another class.
Have you tried using what's it called? Collab?
Yeah, how would that work? And let's just set up. I guess we can use that. Yeah, I'm not sure.
Well,
I guess we can have our own environment, OpenAI Gym, and then do all the training there, and then transfer it here to some extent.
Yeah, you just need to collect the data or something, and then transfer it to Collab. We can talk about it if it.
Okay.
Can try and find some way to get it done, but
okay.
Hope maybe somebody on your team has not burned their $300 of Google Cloud.
Yeah, maybe we can try that. Yeah, that's good. Thanks.
Yep. Are there a lot of people who are planning to do RL? We only have. We've had 2 project proposals come in. one of
Yeah,
them
that's
doesn't
my
look
bad.
to
I
have.
set the deadline to midnight by accident.
Yeah. So one of them doesn't seem to use RL, and the other one is proposing doing some opponent modeling with RL. Quick, like, vote in the class, like, who needs GPU resources, who doesn't have them. So we have currently one team. If you don't tell me, I can't help you. But so one team, we can talk to AWS or Google and see if we can find anything for you. I mean, on another note, it might be surprising, but the kinds of machine learning that you might do in this project probably don't need a GPU. In fact, they may run faster on the CPU.
Yeah, I was gonna say, training these kind of things might be just faster on the CPU, but yeah.
So, in the most recent paper that we wrote, we only use CPU. Goes faster and cheaper. And I think somebody chimed in that they had tried this on a VM and it worked fine, which is excellent to know. Thanks.
Should we go to one-on-one time slots now?
Yeah, one more comment. I suspect if anybody has Mac OS, that it would be possible to install all this stuff on Mac, but we haven't verified it.
It should be possible, but there's no way to interact with the underlying ROS unless you,
You
have
have another container.
Yeah.
Which would have most, because it would be pretty easy. Windows, none of us have a system to check that with, so can't help there. Okay, how are we going to do the one-on-one stuff, Billy?
I think we just go by team number in a different meet or something. Is Rahul still here?
Yeah, I'm here.
Oh,
So
okay.
what we'll do is I'll give out a schedule now, and then each of the teams can just dial in starting from team one onwards, uh, and you can just stay on this call, and then you can just come back to this call when your time is there. So we'll start from 3:50 to 4 p.m. onwards for team one, and then so same thing for team two. I'll send this schedule out. Team two will be 4 to 4:10. I'm just typing this out, and then we'll do that for each of the teams. So for 4:20, and so team four will be from 4:20 to 4:30, and then team five will be from 4:30 to 4:40. I posted that in the chat. You can just copy this somewhere because then you'll have to leave the call. So we'll start with, so everyone but the team. So when you come on the call, the first thing you need to do is, share your screen with your document and walk us through first with what you understand about what you need to accomplish for each of the milestones. We just want to hear it in your words. We've told you that in our words, but we want you to understand what you're going to do. And then we want you to walk us through what you plan to do for the project, and then we'll have the second half of the 5 minutes for discussion, and then we'll repeat this next week too. So let's get started now. So everyone, any questions regarding this? So you can share whatever documents you have right now and on the screen. The submission deadline is tonight. So now everyone but team 1 should drop from the call, and then team 2, 3, 4 just come back to this call after 10 minutes. Billy, you can stop recording.
Okay.
All right, guys. So we'll talk to team 1.